So if we will have a LISA detector and we can be able to observe the region near to horizon, do you think that we will see firewalls or we will see just a regular empty space there?
So I will comment on firewalls, okay? I have a different view from most of my colleagues. And so I preface this by saying that this is not the view that, I don't know how many, if any, of my colleagues would support my viewpoint, but it's the following. That I find firewalls so strange that I am quite prepared to, and find quite attractive, the idea that information is lost. And I see an attractive way that this occurs if the most fundamental formulation of quantum theory is Feynman's path integral formulation. Then that is readily adapted to loss of information, readily adapted to non-unitary evolution. And the simple way in which this happens is in Feynman's formulation, you compute probability amplitudes to go from this initial state to this final state by summing over histories. Wheeler has long speculated long ago, that in that sum over histories you should include changes of topology, and I would argue in the same spirit you should also include finite probabilities for histories that have closed time-like curves. The moment you put in a history that has closed time-like curves, you lose unitarity. But you can still analyze the evolution and compute a probability amplitude to go from here to there in the presence of closed time-like curves and non-unitary evolution by using, for example, the Hartle-Gell-Mann variant of Feynman's sum over histories, their generalized quantum mechanics. And that is readily capable of dealing with these kinds of things. And that kind of formulation, in the absence of closed time-like curves, you just get ordinary quantum mechanics, but in their presence you get a capability of dealing with things like loss of information down black holes, loss of information that is tied into there being finite probability amplitudes for in the sum over histories, for histories where there are closed time-like curves in the, say, in the vicinity or in the interior of the black hole.
So to summarize, you think firewalls do not need to exist?
If I'm right, that the Feynman approach, as for example generalized by Hartle and Gell-Mann, if that's correct, then you don't need firewalls. You don't need any of the struggles that that today's very best theoretical physicists are going through to deal with information loss. You just don't need it. But you have to open yourself up to conceding that, or speculating that the standard Hamiltonian formulation of quantum mechanics is not the ultimate correct formulation, that it is some variant of Feynman's sum over histories.